We're going to start looking at some calculations with linear relations, and we're going to start with the slope of a line. So some roofs are steeper than others. The steepness of a roof is measured by calculating the slope of the roof. Slope can be said to be the rise over run. And we can relate this back. The rise is the change in y over the change in x. So this sounds familiar. This is going to be very closely related, aka the same thing as the rate of change. So the rise is the vertical distance from the bottom of the edge of the roof to the top. The run is the corresponding horizontal distance. So we have roof A, B, and C here. And roof A, I can see that the rise is here. Let's see if I can make that a bit better. So the rise is here in each of them. All right, so in A, I would say that the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units, whatever we're measuring in. In B, the rise is 1, 2, 3, 4, 5, 6, 7. And in roof C, the rise is 14. So I'm just going to write that out just to make sure that we're staying on top of things. All right, now the run in each case would be the horizontal distance. So in roof A, the run is 13 units. In roof B, the run is 12 units. And in roof C, the run is 8 units. So using our idea of the rate of change, the slope is rise over run. For roof A, the slope will be 13 over 13, which is 1. That means that it has an equal amount of rise as it does run. So these two sides are equal. This would be an isosceles triangle. Roof B, we have slope is equal to the rise over run, which we get 7 over 12. And we can't simplify that, and we won't divide it. We are going to leave it as a fraction. So if your slope is not a whole number, leave it as a fraction. Just reduce it if possible. So last one, slope is rise over run. So 14 over 8. We can simplify that down to 7 over 4. And because it would lead to a decimal value, I'm just going to leave it as a fraction. So the slope of a line segment on a coordinate grid is the measure of its rate of change. So recall that the rate of change was equal to the change in the dependent value over the change in the independent. And again, this was the change in y over the change in x. So determine the slope of each line segment. Again, slope is rise over run. So in this case, our rise, again, is 9, and our run is 6. Make sure that you know that each one of the increments on our graph or our scale is 1. We may need to adjust how we're counting to attribute to that. So the rise is 9 over 6, which can be simplified to 3 over 2. In this case, going from left to right, which is how we're always working, our rise is negative. We are going down when we are going left to right. So our rise was -3 in this case. And the run is 9. So our slope is rise over run. And rise was -3 over 9. We get -1/3 as our slope, which makes sense. We have a negative rate of change, so a negative slope in this case. So we have 4 cases for the slope of a line. It can be positive, so up and to the right, where both the rise and the run is positive. It can be negative, where the rise is negative that we just saw, and the run is positive. Again, we're always measuring or counting from left to right across our points. It can be 0, where in this case, the rise was 0. And it can be undefined, where in this case, the run was 0. It did not move left to right. Because slope is rise over run, if I have some value, let's say 1, 2, 3, 4, 5, 6 over 0, you cannot divide by 0. So this is an undefined slope. Draw a line segment with each of these slope values. So 4 over 9, remember slope is rise over run. So that is 4 over 9. This means that the graph rises 4 and runs 9 from some point. So let's choose any point. I'm going to choose this one here. Actually, sorry, just to stay constant with my notes, just in case you're looking at both the completed notes and this, I'm going to start here. So we need to rise 4. So 1, 2, 3, 4. And then we need to run +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. From here, we will connect our 2 points. Oops, using a ruler if you've got one handy. All right, our second one here, rise over run, is equal to -8 over 3. So we'll start up here. You can choose any point. Your graph can start anywhere, unless it was specified, I suppose. In this case, because it wasn't, we can start with any point. I need to go down 8. So our rise is -8. So 1, 2, 3, 4, 5, 6, 7, 8. And run, we're going to move 3 to the right. So our final point is there, and we connect with a straight line. Now, what happens if I would have given you just a whole number? Let's say the slope equals, 2. Well, rise over run is equal to 2. 2 is technically over 1. So let's just add this to our example. Let's start right at the center here. We need to rise 2 and move over 1. So if you wanted to, you could continue on. So we can rise 2 over 1, rise 2 over 1, and you can continue on in this fashion, and that will show you exactly where that line goes. So you don't just have to apply the slope once when you're graphing. You can apply it as many times as you would like. We can show that the slopes of all segments of a line are equal. So we're going to calculate the slope of the line for all of these different evaluations. So I'm going to start with W. So W, the slope, is rise over run. Notice that I'm writing my formula each time I start a question, just to show what I'm using and remind myself of the formula. So the rise was 4 units and the run is 6. And they're actually denoted here, so they've simplified for us, which is 2 over 3. If we look at V, we're going to calculate the slope for V, which is rise over run again. I'm not going to write it this time. I've already written it once for this question. Our rise is 8, and our run is 12. When we simplify, we get down to 2 over 3 again. Our last one, let's calculate the slope for U at point U. So the slope will be 12 over 18, which once again can be simplified to 2 over 3. Note that the slope is unchanged no matter where it is measured from, to, or to on the graph of a linear relation. So we could measure between points S and P, or T and N as well, or any other point on this line and get the same result for the slope. Another formula for slope of a line is M, which is slope. So M is the variable for slope, which again was rise over run. So the rise in this case is the final point minus the initial point in the rise. So y2 minus y1 all over x2 minus x1. So this just denotes the change in y over the change in x, because when we're measuring change, it's always final minus initial. So determine the slope of a line that passes through E, which is 4, -5, and F, 8, 6. So because we don't have a graph, we can easily use our new equation. So we're going to use M is equal to y2 minus y1 all over x2 minus x1. So to get started, we need to decide who is x1, y1 and who is x2, y2. So I'm going to write out our points, and let's just let E be 0.1 and we'll let F be 0.2. It actually doesn't matter which ones you choose. If you want to label yours opposite of mine and prove that to yourself in this question, go for it. So if this is 0.1, this value will represent x1 and this value, will represent y1. And because this is 0.2, F, the x coordinate will represent x2 and the y coordinate will represent y2. So when we sub in, y2 is 6. We need to subtract y1, which was -5. So don't forget to add that negative in. This is all over x2, which was 8. Take away x1, which is 4. So 6 take away -5 is like adding 5 to 6. So it'll be 11 over 4. And that is the slope of the line between these 2 points. All right, my graph seems to have disappeared for example 4 here. So I'm just going to quickly draw it out with you. So it says that Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. Tom plotted his data on the graph. So we have time down here, which was in hours, and that was 2, 4, and 6. And it went up by increments for pay, which was in dollars, of 24. So 24, 48, and 72. And we had a point here, here, and here. Now that's a terrible graph, but it will do for our circumstance. So what is the slope of the line through these points? You can either determine the rise and run for these points, but make sure you consider that each square on our graph does not necessarily represent a rise of 1. In this case, each square on our graph represents a rise of 12. Therefore, the entire rise here was 24, and the run in this case was 2. So just be sure you're reading the graph. Alternatively, you can write the coordinates for these points. So that's what I did. I wrote the coordinates for each point. We have 2, 24, and 4, 48. Then I can just use my general slope equation. So what is the slope of the line through these points? Well, M is equal to, y2 minus y1 over x2 minus x1. So I'm going to say that this is 0.2 and this is 0.1. On our graphs, typically we'll label them left to right as well, but it does not matter. Just stay consistent. The y value for 0.2 is 48. The y value for 0.1 is 24. The x value for 0.2 is 4. The x value for point 1 is 2. So 48 take away 24 is 24. 4 take away 2 is 2. And so we get a slope of 12. What does the slope represent? Well, let's go back and put in units. So the change in y is representing dollars. X is representing hours. So when we divide our cash per hour, I get something like $12 per hour. What does this slope represent? It represents a wage. So Tom makes $12 per hour. So how can the answer to part B, aka our slope here, and the units, be used to determine how much Tom earned in 3.5 hours? Well, we know that wage times the time worked is equal to your take-home pay. So if that's the case, $12 per hour times 3.5 hours gives us $42. So Tom will earn $42 in 3.5 hours. Alternatively, you can use unit analysis here. So 3.5 hours was what we were starting with. To cancel hours and change it into cash money, that's $12 per 1 hour. Hours cancel, and you're left with just a value or unit of dollars. 3.5 times 12 is $42. The time it took Tom to earn $30. So if we want to solve for time in this equation, we need to divide both sides by wage. So your pay divided by your wage will equal the time you spent working. So if he earns $30 and his wage is $12 per hour, dividing those two, you get 2.5 hours. Alternatively, again, you can use our unit analysis. We're going to start with our $30 here, and we need to cancel dollars and find hours. This is $12 per 1 hour. The unit of dollars cancels, if you will, and we multiply 30 by 1, divide by 12, and you get 2.5 hours. So when you look at a line on a grid, how can you tell whether its slope is positive, negative, 0, or not defined? Again, if a line is moving up and to the right, it is positive. So up and right. If it is moving down and right, it is negative. If it is flat, so the rise is 0, the slope is 0. If the line is vertical, the slope is undefined. Why can you choose any 2 points on a line to determine its slope? Because the slope of a line is constant, it doesn't matter where you choose your points. The slope will be the same regardless. When you know the coordinates of 2 points, E and F, and use the formula to determine the slope of EF, does it matter which point has the coordinates x1 and y1? AKA, does it matter who you label as point 1 and point 2? No, it does not. If you're not sure, go back and label opposite of my point 1 and point 2 in a question and prove that to yourself.